Hi, chemistry students, and welcome to our class number 1 in week 9 about the intermolecular forces. The learning goals for this class, we are going to identify the intermolecular forces, and we want to predict the state of matter based on the strength of the intermolecular forces. And the third learning goal is to predict which compound has a higher or lower boiling point based on the intermolecular forces. So, like this slide shows that some questions can be answered and can be explained about the explained according to the intermolecular forces. So, what is the definition of the intermolecular forces? The intermolecular forces are attractive forces. So let's underline this word. It is attractive forces between molecules, and this is another important point. It is between molecules, not like it is between the molecules, and occur when there is a variation in the electron distribution in the molecule. Let's see this molecule. This is HCl. And this is a polar covalent bond between the chlorine atom and the hydrogen atom. And we said that the chlorine is more electronegative than the hydrogen. So that's why we will have partial negative on this side, and we have partial positive on the other side on the hydrogen. And we talked that in details when we were talking about the molecular compounds. This is another molecule. So between the two molecules, there will be intermolecular forces, which is represented by these dots. And the intermolecular forces are weaker than the ionic and the covalent bonds. And also the intermolecular forces arise when there is partial negative charge on a molecule is attracted to a partial positive charge on another molecule. So can you see this is the partial negative on the chlorine, partial positive on the hydrogen, and we have intermolecular forces between the two molecules. Let's revisit what we have studied in week 8 and 7 about the dipole and the bond polarity. We said that a polar covalent bond becomes more polar as the difference in the electronegativity increase. And we remember that when we were drawing the polar compounds, we say that, for example, the oxygen has a higher electronegativity than the carbon. So the oxygen will be partial negative and the carbon will be partial positive. And we draw an arrow directed from the positive side to the negative side. And we say that's dipole. So that's the dipole, and this is the way to represent the dipole. This is the nitrogen and oxygen, chlorine and the fluorine. So as the electronegativity difference, which is represented by delta E, as the electronegativity increase between the two atoms, so the compound will be more dipole, or the polarity will increase. Okay? So molecules attract each other when the positive end ends up near to another molecule's negative end. And we talked that, like for example, the HCl. And here we have the HCl molecule that was in the previous example. So there will be attraction between the positive end and the negative end. We have 4 types of electronegativity. We have 4 types of intermolecular forces. The first one is called London force or dispersion forces. The second one is called dipole-dipole attraction. The third type is called hydrogen bonds, and the fourth one is called ion dipole bond. We are going to speak about them in details in this class. And you can see that the strength, the London force is very weak, while the ion dipole bond is very strong. So let's begin from the weakest to the strongest. The dispersion force or the London force are very weak attraction force, and it is between non-polar molecules. Let's have an example: the fluorine atom or the hydrogen atom. When they are bonded together, they will make a molecule, and this molecule is non-polar molecule because the electrons are distributed equally. But for instance, there will be a temporary or induced dipole that makes on one end it will be partial negative and the other end it will be partial positive. So there will be attraction between the molecules, but these intermolecular forces is called dispersion force or London force, and it is very, very weak forces. So the London forces between happens or occurs between the non-polar molecules. The second type is dipole-dipole attractions. And the dipole-dipole attractions, it occurs between the polar molecules. Let's, for example, we have the HCl, like this is the example we have drawn, for example, and this is HCl. So, and here we have HCl. So this is a molecule, and this is another molecule. So we have here partial negative, and we have here partial positive. So there will be intermolecular forces and between the polar molecules, and this is very important. The molecule must be polar molecule, and this is permanent because the electrons are distributed unequally. The chlorine is more electronegativity than the hydrogen, so it will attract the electrons towards it. These attractions are stronger than the London force because the dipole of polar molecules is permanent. So the dipole in the polar molecules are permanent, while in the polar, the dipole in non-polar molecules are permanent. That makes the dipole and the intermolecular forces are more stronger than the London force. Let's go to the third type, which is the hydrogen bond. And actually, hydrogen bonding is a branch. We can consider it's a branch from dipole-dipole interaction. And in the hydrogen bonding, we have one molecule has hydrogen atom, and the other atom, maybe it will be fluorine or oxygen or nitrogen. And in this case, there will be the intermolecular, that will be dipole-dipole interaction, but because it is the interaction between the hydrogen atom and the fluorine atom, that will make it very strong, stronger than very strong version. So that's a very strong dipole-dipole, and it is from strong dipole attraction called the hydrogen bonds, and it between hydrogen atoms bounded to fluorine, oxygen, and nitrogen. The fourth type of the intermolecular forces, it's the ion dipole. In case of the ion dipole attraction, the simple example is the sodium chloride when we dissolve it in water. Water is polar covalent bond. Polar covalent compound. While the sodium chloride is ionic. When it dissolves in water, it will dissociate it into ions, which is sodium ion and chlorine ion. Or we say that sodium cation and chlorine anion. The sodium cation, which is positive, will be surrounded by the water molecules, and there will be attraction force between the positive ion and the partial negative side of the oxygen. This is the oxygen and this is the hydrogen. While the chlorine on the other side, Cl, will be surrounded also by water molecules, but from the positive side of the hydrogen. And there will be attraction forces. This type of attractions is called ion dipole. So in the ion dipole, we have two things to put in our mind. We have ions and we have polar compounds. So we have ions and we have polar compounds. So in this map, we can find out or differentiate between the fourth type of the intermolecular forces. First of all, I will ask myself, is the molecules I have, there is ions? If yes, so I'm asking myself again, are there is polar molecules and the ions both present? If yes, so that will be the ion dipole. The example when we dissolve the sodium chloride in the water. But what if there is no? I will ask myself, is this compound polar or non-polar? If it is non-polar compound, so it will be London force, which is the very, very weak intermolecular forces between non-polar covalent compounds. Example, the hydrogen gas, the oxygen gas, the methane. But what if they are polar compounds? So in this case, I will ask myself, are hydrogen atoms bounded to fluorine, oxygen, or nitrogen atoms? If yes, so that will be hydrogen bonding. So in case of hydrogen bonding, it is polar compounds, and we have hydrogen bounded to fluorine, oxygen, or nitrogen. Like the hydrogen fluoride, the water molecules, the NH3. If no, so that will be dipole forces, example like as the HCl or H2S. So let's recall the state of matter. When we were talking about the state of matter, we said that we have three states of matter: solid, which the particles are very close; liquids, which the particles are close but mobile; gas, which the particles are far apart. I would like to explain the state of matter according to the intermolecular forces. Look to this example. If I'm looking to the chlorine gas or fluorine gas, that's non that's we will see that they are non-polar covalent compounds, and the melting point, we will observe that the melting points are very low. While in case of solids matter, we will see that the melting points are very high. What did that mean? That means that as the attraction forces or the intermolecular forces between the molecules become more higher or more stronger, so as the intermolecular forces becomes more stronger, that means that the melting point will be higher. So as the stronger attractive forces is typically found in solids, whereas weaker forces are seen in liquids and gases. Finally, let's have a summary of the intermolecular forces. As we said that we have four types of intermolecular forces. The first one is London forces, which is the weakest, and it is between non-polar molecules. The dipole-dipole interactions, and that's between polar molecules. The hydrogen bonding, which is between polar molecules with hydrogen covalent bonded, or to oxygen, nitrogen, and fluorine. Very important. Don't forget that. On the molecule, we have one side as hydrogen, the other side as oxygen, nitrogen, or fluorine. The ion dipole, which is the strongest, it is ion attracted to partial charge on polar molecules. So this is the four types of the intermolecular forces. Thank you very much and see you in class.